Properties of a vector space. A vector space is defined as a non-empty set V of objects called vectors, which are defined by two operations, addition and multiplication by scalars, or real numbers. The following 10 axioms must hold for the vectors u, v, and w in the set V and for the scalars c and d. 1. The vectors u plus v is in the set V. 2. The sum of the vectors u plus v is equal to the sum of the vectors v plus u. 3. The sum of the vectors u plus v plus the vector w equals the vector u plus the sum of the vectors v plus w. 4. The vector u plus the 0 vector equals the vector u. 5. The vector u plus negative u yields the 0 vector. 6. The scalar c multiplied by the vector u is in V. 7. The scalar c times the sum of the vectors u plus v equals c times u plus c times v. 8. The sum of the scalars c plus d times the vector u equals c times u plus d times u. 9. The scalar c times d times the vector u equals the scalar c times d times u. 10. The scalar 1 times the vector u equals the vector u. Properties of a subspace. A subspace of a vector space V is a subset H of V. 1. The 0 vector is in H. 2. The sum of the vectors u and v is also in H. 3. The product of the scalar c and the vector u is in H. There are many real-world applications for vector spaces. Most have vectors as functions with a value. We usually think of vectors as arrows, but they are actually abstract mathematical objects with particular properties. In the study of signals, periodic functions are decomposed into possibly infinite linear combinations of basis functions. That combination is called the Fourier series. Fourier analysis, the study of the Fourier series, is a common technique used in engineering. The vector space for Fourier analysis is the Hilbert space and is of infinite dimensions. Fourier analysis allows us to digitally filter signals such as radar and radio. To expand on that, let's say we have a radio that accepts a range of frequency as its input. When a digital filter is applied properly, it would decompose the signal according to the contribution of each frequency, and it will output one frequency's contribution and truncate the rest. This is the reason we only hear one radio station.